Good morning. Today I discuss some of the problem questions in the previous question papers. The first question is calculate the lattice constant of NaCl given that molecular weight of NaCl is equal to 58.45 and density is equal to 2.17 into 10 raised to 3 kilogram per meter cube, and Avogadro number is given as 6 into 10 raised to 26. If the Avogadro number is given in 10 raised to 26, the weight will be in unit kilogram. If it represents in grams, Avogadro number is taken as 6 into 10 raised to 23. Okay. Here our question is, we have to find the lattice constant A. And here we know that the lattice constant, the expression for lattice constant, that is equal to A is equal to N into MA divided by Na into rho raised to 1 by 3. Here the quantities N is equal to the number of atoms in the unit cell of NaCl. We know that the number of atoms in the unit cell of NaCl, that is equal to 4. And Ma is the atomic mass that is given in the problem, that is equal to 58.45, and rho is the density. It is also given as 2.17 into 10 raised to 3 kilogram per meter cube, and the Avogadro number is given as 6 into 10 raised to 26. So when we substituting this quantity, that is, we have A is equal to the number of atoms in the unit cell, small n is equal to 4, that into 58.45 divided by 6 into 10 raised to 26 into 2.17 into 10 raised to 3 whole raised to 1 by 3. Then it can be obtained as 5.64 into 10 raised to minus 10 meters. Here the question is, although it is a direct one, but here the value of small n, the number of atoms in the unit cell of NaCl to be known. So, okay, in the case of sodium chloride crystal, we know that small n is equal to 4. It is the additional information for this problem. Okay, so the connection between the lattice constant and density is given by this equation. A is equal to n ma divided by na into rho all raised to 1 by 3. Okay, and some questions related to this one, which is asked in the previous questions, is discussing in the next slide. Here the question is, lattice parameter and the atomic mass of diamond crystal are 3.1, 3.57 angstrom and 12 respectively. That is, given that lattice parameter A is equal to 3.57 angstrom, or that is equal to 3.57 into 10 raised to minus 10, 10 raised to minus 10 meter, and the atomic mass, it is equal to 12. That means 12 AMU, atomic mass unit. Okay, here we have to find the density. We have to find the density. So in the previous question, we have used A is equal to N into Ma divided by Na into rho whole raised to 1 by 3. When taking cube of both sides, we will get A cube is equal to N Ma divided by Na into rho, from which we can obtain the expression for rho is equal to n into ma divided by na into aq. Here ma is given and we have the Avogadro number. We write here it is 10 raised to 26. Okay. Here I write 10 raised to 26. So the density will be in kilogram per meter cube. Okay. And we know that what is small n here? N is equal to the number of atoms in the unit cell of diamond. In the case of diamond, the number of atoms in the unit cell, it is equal to 8. Okay. Then we substitute here, it is equal to 8 into 12 divided by 6 into 10 raised to 26 into 3.57 into 10 raised to minus 10 whole cube. Okay. Then the result must be equal to 3528 kilogram per meter cube. Okay. Here, if we used 6 into 10 raised to 23 for Avogadro number, the result must be in gram. Then here additional 3 digit will be there. Okay. Then dividing that quantity with 10,000, sorry, 1000 or 10 cube, we will get this as the answer. Okay. The question about diamond crystal, the same question is asked 2 more times in the question paper. Okay. The question was like this: lattice parameter and atomic weight of diamond crystal are 3.57 angstrom and 12 AMU respectively. Calculate the density of the same given. In that case, n is equal to 6.023 into 10 raised to 23 per mole is given. Then the answer you obtain will be in the unit, density will be in the unit gram per meter cube. Okay. Then we have to change it to kilogram dividing by 1000. Okay. The same question. Now we go to the next question. Calculate the interplanar spacing for 321 plane in simple cubic lattice with interatomic spacing A is equal to 4.21 angstrom. In this type of question, you should verify the question, because in some cases they will give you the atomic radius, not the lattice constant A. If it is given the atomic spacing in the simple cubic crystal, it will be the same atomic radius, lattice constant, and the atomic spacing. Okay. If in some cases the atomic radius is given, we must find the lattice parameter A first. Okay, then we have to find the interplanar spacing. So the expression for interplanar spacing, D is equal to A divided by root of h square plus k square plus L square. Here HK, L are the Miller indices. They given in the question HKL 321 and A also given. A is equal to 4.21 angstrom, or that is equal to 4.21 into 10 raised to minus 10 meter. And the HKL parameters also given, or that is equal to 3 to 1. Okay, then this is a direct substitution, that is 4.21 into minus 10 divided by root of 3 square plus 2 square plus 1 square, that is equal to 4.21 into 10 raised to minus 10 divided by root of 14. If it is evaluated, you will get that is equal to 1.125 into 10 raised to minus 10 meter. This is the answer. The next question, find the interplanar spacing for the lattice planes of Miller indices 321, 210 and 111 for cubic lattice with A is equal to 562 angstrom. We know that the general expression for D is equal to A divided by root of h square plus k square plus L square. Here the value of A is given as 5.62 angstrom, or that is equal to 5.62 into 10 raised to minus 10 meter. First we have to find D321. Then it must be equal to the value of A is equal to 5.62 into 10 raised to minus 10 divided by root of 3 square plus 2 square plus 1 square. It will be obtained as 1.5 into 10 raised to minus 10 meter. And the next 4 D210, that is equal to 5.62 into 10 raised to minus 10 divided by root of 2 square plus 1 square plus 0 square, that is obtained as 2.51 into 10 raised to minus 10 meter. The next is D of 111, that is equal to 5.62 into 10 raised to minus 10 divided by root of 1 square plus 1 square plus 1 square, that is obtained as it is equal to 3.245 into 10 raised to minus 10 meter. Okay, is it clear? The next question. In this question, the atomic radius is given. Look at here. Copper has FCC structure of atomic radius 0.1278 nanometer. Calculate the interplanar spacing for 321 plane. Okay. Here, the expression for T is equal to A divided by root of h square plus k square plus L square. But here A is unknown. A is equal to 2 root 2 R for FCC. In this structure FCC, A is equal to 2 root 2 R. Okay. Then first we find the R is given as R is equal to what? 0.1278 nanometer. 0.1278 into 10 raised to minus 9. Okay. So that is equal to 2 root 2 into the value of R is here 0.1278 into 10 raised to minus 9, or A is obtained as 0.3615 nanometer. So the value of A is obtained. Then we have to obtain D of 32. Then it is equal to 0.3615 into 10 raised to minus 9 divided by, here the value of A is obtained as 0.3615 nanometer, or that is equal to 0.3615 into 10 raised to minus 9. Okay, root of 3 square plus 2 square plus 1 square, that is obtained as 0.0966 nanometer. This is the answer. The next question is, the interplanar spacing for 110 plane is 2 angstrom for a cubic crystal with FCC structure. Find the atomic radius. Okay, here the planar spacing is given. D is equal to D110, that is equal to 2 angstrom, or that is equal to 2 into 10 raised to minus 10 meter. D is given. Okay, and the HKL values is 110. We have to find R. So first we have to find the value of A. We know that B is equal to A divided by root of H square plus K square plus L square, or A is equal to what? D into root of H square plus K square plus L square. So here D is equal to 2 into 10 raised to minus 10 into root of 1 square plus 1 square plus 0 square. So I write it this way. This will give 2, sorry, root 2. Then 2 root 2 into 10 raised to minus 10, because I am not find the answer, because here we know that for FCC structure, A is equal to what? A is equal to 2 root 2 R. Okay, then if A is equal to 2 root 2 R, then we can obtain R is equal to A divided by 2 root 2. Okay, this is the expression for A, and A is equal to 2 root 2 into R. Okay, so from here we can find R is equal to what? A divided by 2 root 2. So R is equal to A divided by 2 root 2, or that is equal to A divided by 2 root 2 must be equal to 1 into 10 raised to minus 10 meter. So this is the value of atomic radius. The next question is that is connected with Bragg's law. Find the interplanar distance of sodium chloride crystal which produces first order diffraction pattern at an angle 30 degree when X-rays of wavelength 0.05 nanometer are used. Here the main expression is 2D sine theta is equal to n lambda. Okay, here theta is the glancing angle and d is the interplanar distance and n is the order and lambda is the wavelength. Here n is equal to 1, theta is equal to 30 degree, and lambda is equal to 0.05 into 10 raised to minus 9 meter. Okay, here we have to find the value of d. So d is equal to n lambda divided by 2 sine theta, that is equal to n is equal to 1 into 0.05 into 10 raised to minus 9 divided by 2 into sine 30. Sine 30 is equal to 1 by 2. Okay, then the numerator will be the answer. Then it is equal to it is 0.05 into 10 raised to minus 9 meter. Okay. The next question is a sample of chromium is analyzed by X-ray diffraction using the CUK alpha radiation with wavelength lambda K alpha is equal to 1.5418 angstrom. Determine the Miller indices for the plane from which the angle of reflection is 31.4 degree. The lattice constant of chromium is 2.96. A is given. A is equal to 2.96 into 10 raised to minus 10 meter. Okay. Lambda is given. Lambda is equal to 1.5418 into 10 raised to minus 10 meter. Theta also given. It is 31.4 degree. Okay. We have to obtain the Miller indices for the plane. Here the main expression is 2d sine theta is equal to n lambda. Okay, here the lattice constant is given, and so we know another expression, that is the relation between d and e. D is equal to a divided by root of h square plus k square plus l square. We have to find the value of HKL parameters. So combining these two equations, okay, that is substituting the value of d here, we will get 2a sine theta divided by root of h square plus k square plus l square is equal to n lambda. Okay, then the value of root of h square plus k square plus l square must be equal to what? We taking this denominator this side and this to the denominator, then 2a sine theta divided by n lambda. Okay, here we assume n is equal to 1, the first order diffraction, then substituting the values 2 into a is equal to 2.96 into 10 raised to minus 10 into sine 31.4 divided by 1.5418 into 10 raised to minus 2. This is obtained as it is approximately is equal to some 2.0042 something. Okay, so it is approximately is equal to taken as 2. Okay, because this square root of Okay, I rounded this because first we have to square it. Okay, then it will be when I square it, it is 4 point something. Okay, uh, when we are adding square of some integers, it will not be fractions. Okay, so I omitted, or it can be right this way, and h square plus k square plus l square approximately is equal to 4.00 something. Okay, then it is approximately is equal to 4, and here h square plus k square plus l square is equal to 4. So that combination is possible. It is possible only for combination, only for scale is 200, or the combination of these two, 0, 0, 0, 0, 2, 0, etc. So the HKL parameters must be equal to this one. Okay. The next question is, a monochromatic X-ray beam of lambda 0.7 angstrom, 0.7 angstrom undergoes first order Bragg reflection from the plane 302 of a cubic crystal at a glancing angle of 35. Calculate the lattice constant. Okay. In the previous case, we have write an equation that is 2a sine theta divided by root of h square plus k square plus l square is equal to what? N lambda. Okay. Then here we have to find the value of a here. Then arranging this equation, n lambda m lambda into root of h square plus k square plus l square divided by 2 sine theta. Point 7 into 10 raised to minus 10 HKL values 302, and theta is equal to 35 degree. The lattice constant to be evaluated. The question is not to find t. If only we have to find d, the expression is, we know that we use is 2d sine theta is equal to n lambda. Okay. It can also obtain from this one, because first we find d here. D is equal to what? M lambda divided by 2 sine theta. Okay, first find d and n lambda divided by 2 sine theta. Then multiply it by this quantity. D into a must be equal to what? A must be equal to d into root of h square plus k square plus l square. Here I write the equation as a single one. Then first order 1 into 0.7 into 10 raised to minus 10 into root of 3 square plus 0 square plus 2 square divided by 2 into sine of 35. It can be obtained as 2.2 into 10 raised to minus 10 meter. This is the answer. The next question. Calculate the angle of incidence at which electrons of energy 100 eV must be incident on the lattice plane of a metal crystal in order to give a strong Bragg reflection in the first order, given that lattice spacing is 0.252 nanometer. Okay, here the energy of electron is given. I write it E is equal to 100 eV. Okay, then here the lattice spacing. Okay, lattice spacing is given D is equal to 0.252 into 10 raised to minus 9. We have to evaluate theta. Okay, here this is the case of Bragg's diffraction. So the equation is 2d sine theta is equal to n lambda. Here n is also given. N is equal to 1. D, we have to find theta. Theta is equal to what? Then we have to write, we have divided sine theta is equal to n lambda divided by 2d. But here lambda is unknown, but E is given. The energy of electron is given. When we looking at the energy is very low when we compare with its rest mass energy. So it is a non-relativistic electron. Then the lambda of it is the de Broglie wavelength, okay, or that is equal to h divided by root of 2me. Okay, we can substitute the value of h and mass of electron and the energy of this, or another expression is there in the case of electron. An electron of the lambda of electron, okay, an electron having energy E, okay, then it's 12.25 divided by root E, this angstrom. This is the, this will be the next simple expression for it is the values of h and m is m and 2 is substituted, only root E is remaining in the numerator denominator. So lambda is equal to, from this lambda is equal to what? Lambda is equal to 12.25 into 10 raised to minus 10 divided by root of 100. Okay, then it is equal to 1.225 into 10 raised to minus 10 meter. So the lambda is also obtained. Then it is equal to 1 into 1.225 into 10 raised to minus 10 divided by 2 into 0.252 into 10 raised to minus 9. It can be obtained as 0.242. So sin theta is equal to 0.242 or theta is equal to sine inverse of 0.242. It is approximately is equal to 14.1 degree. So this is the answer. So this is the questions asked from the crystal physics and Bragg's law. I have also discussed the questions from superconductivity, the chapter superconductivity as a different section. Thank you.